Hi guys, we are Team6, and this is the project presentation for Software Engineering 502. The project is to develop a programming language that can take care of some of the project criterion. And my name is Akshay Kumar, and my other teammates will be representing themselves.
Hi, this is Sharon, and I'm part of Team SARS.
Hi, this is Riya Mehta.
Hi, this is Suraj.
Okay, so language is called SARS, which is an abbreviation of our first names. This is the content I'll be going through today. So we are generating tokens with the Python file, lexer.py. Then we are using those tokens to generate a parse tree. And this is the design of our language. Every program has a begin and an end. The program needs to have a .sar as extension. And after the tokens are generated, we will send it to the Prolog compiler to compile it and finally give the output. This is the flow of the processing that I just described. We generate the tree, we give the parse tree to the Prolog, and then we get the output. The compiler we are using is Prolog, and you need a Python 3 library and SWR Prolog to run this. This is our grammar. We're going to further discuss this after the PPT. The data types we are using are int, Boolean, and string. We have the 4 basic arithmetic operations and the relational operators like equal to and not equal to and greater than and so on. We also support increment and decrement operators. We have the ternary operator feature as well, which is the same as C++, where you evaluate a condition and then if it's true, you print this part of the block. If it's not, you print this part of the block. We have general statements like print, declaration statements, assignment statements, if condition, where else is optional. It can be if and else, or it can be if condition, and that's it. We have 3 types of loops, 2 types of for loops and 1 while loop. There's a simple C++ type for loop, a simple for loop, and a for loop that takes in the range and then runs till it is evaluated all the numbers in the range. And there's a simple while loop with a condition and a block. Okay, to run a program, you need to open Swipel on your terminal. You need to compile your sars.pl file, and then you need to run the program using this command. This is an example program, and according to the flow, we have the we have the execution right here. So yeah, so you compile the PL file and then you run the command that was mentioned in the previous slide, and then you get the output. This is the output we get from the lexer file, which is just tokens of the program. After the program runs through the grammar, a parse tree is generated and we get the output, which is the final output.
So this is the lexer file which SARS is going to handle. So first we just open the file which the user gives us, and then we're going to remove all the spaces and the unwanted tabs. And first thing we're going to do is check for all the keywords, like we're going to begin and all your data types in string and everything that you can see here, that we're going to take those out and put them as tokens. The second and priority which we are going to do is we handle for separately here, And here, as you can see, this is only for in range for, not the generic one. The generic one still just passes into the next part of the program where we evaluate it separately. So that's for loop. And here we handle the rest of the all your tokens which we need. First we're going to see is the not. So this is just a basic if condition. If we hit a not, we're going to put it in a token and remove it from the file. And then here we're going to see int, and this is specifically for the for loop, because this is not the common assignment. This is only for loop handling. The common int is going to just hit from the first criteria where we saw the handle the words. And once we go through int, it's just flat all the characters which are there in the list. And after this is like only for the assignment operators. After the assignment, we're usually we'll end up with a variable or a integer. So this handles them separately. And if it's a string, it's going to go through here and take the say quotes separately and then the text separately. If it was a number, it's just running through here and we'll get the number separately. So by the end of this, we're going to have all our tokens except for the brackets, which we are going to handle it at the last. So when we run the file, we're going to get tokens list like this, which has begin and your brackets, integer, then your assignments and everything as a separate token, and they're split, as you can see, by a comma, and they're enclosed by a quote, single quote. And the numbers alone don't have quote because they're int. The rest all is tokenized.
Hi, this is Suraj, and I'm here to demonstrate you about the parsing of language SARs. And we are using we are implementing our parsing in Prolog. Coming into the parse tree, we are executing block-wise, where we employed like three types in our language, which are integer type, int, string type, string, and boolean type, bool, in our language. Coming to the semantics part, predicates like lookup type, and update. Going to the semantics part, each block will be evaluated one after the another, and declaration just updates the value of the identifier. Assignment updates the value of the given identifier, and 4 types of conditions with 6 conditional operators: equal to, not equal to, less than or equal to, greater than or equal to, less than and greater than operators. And coming to the print, we'll be writing each and every if condition. We are employing 2 types of if, as in the presentation, one with no else part, the other with an else. Coming to while part, we are evaluating the condition in the while first, and then evaluating the block, and updating the environment, and evaluating the new evaluating the condition in the new environment until the condition is true and false. If it stops updating the environment and gets out of the while loop.
Okay, so I'll be continuing from the for part of the loop. So the for loop is similar to how the while loop ran. Basically, the condition true, a block will be satisfied. For the condition false, another block will be satisfied, and that's how the for loop will be evaluated. There are 2 types of for loop that we are trying to generate. One is the for loop that's of the generic type, which you will find in C, C++, and Java. The other type of for loop is something similar to the type that you'll find in the Python. So that one is similar to for range. So for in range of some number colon some other number. Then we have a ternary operator. A ternary operator is condition one, question mark condition 2, colon output 1, colon output 2. So that's how the ternary operator generally looks like. We also have the iter values because we needed to keep the for loop as generic as possible. So in a in a C++ or C type for loop, we have I++ and I minus minus as a, and after that, the eval expression term is similar to all the expressions that are needed to be evaluated, which we have already gone through in our assignment, and it's similar to the ones that we've gone through in our assignment. And that will be the end of our evaluator. So I'd like to show you how this entire program runs as an integrated model, because we needed it to be a single command line executable SARS predicate. So the SARS predicate will actually create a process. We use a Python lexer, and the output from the Python lexer is taken as the input for the program. So in order to do that, we had a problem where we needed to bridge the connection between a normal terminal and an SWIPL, which is the generic SWI Prolog terminal in most operating systems. Also, you have gprolog, I guess, which is another operating system, but we are personally using SWIPL. Okay, so we created something called as a process create, which will take the path of Python 3.7, which is our Python version that we are using. And then we take in two variables called as the lexer name and the file name. So the lexer name is the absolute location of the lexer file, which currently for me is over here. This is my lexer file. And the output of the lexer file is just tokens. That's it. And coming back to the SARS-PL, and then we need the file name. This is the absolute location of the file, which has a SARS extension that we need to compile and execute. So that is the file name that we need as an input. The std output will take in any output that is generated by the lexer, and will read that in and put it into a variable called x. Because anything that's outputted or read by the std out as is in a string format, our list will be in strings. So we convert the strings to a term, and that's why we use the term to atom. And after term to atom is done, we run our program. This program generates our program parse tree. So that output will be generated from the tree, and then the program semantics will take in the tree as the input, and the output over here is actually the environment, which we do not need. Our programs or our language is written in such a way that all of our output will be displayed using the print statement within the language itself. So I'll just show you an example of how this is executed. We will first go into the SWIPL terminal, and this currently we are in the SWIPL terminal, as you can see. After that, we will first have to compile the PL file, because this PL file contains all the predicates that we need, which is the integrator, which has the parse tree generator and has the evaluator. So we'll take the absolute path for this, and I'll just compile this. It has singleton warnings. Then we will just have to call SARS, which is our predicate name, and then two files are needed. Sorry, two paths are technically needed as an input for this program to run. So just one second. So the first one that I'm going to take is the lexer. So lexer's path is going to be taken and put in here as the string. So lexer is done. And then the second one will be the file name. The file that I'm going to run is called basic.sars. It's the same file that Ria showed you in the project PPT. So you can take that over here and Control V. And after that, once you click enter, the entire program evaluates. And I will show you the program itself so that we can cross-reference this. Just one second. So int x initializes the variable of x to type int, y type int to y. Then the values are generated, put into the corresponding variables. And after that, we are printing x and printing y, which is the outputs over here. So x is 5 and y is 10 as given. And then we are just barely doing increment operation. So x is equal to x plus 1, and we're printing that, and that is also working. And then we're printing a string. So this kind of puts in perspective how all of our data types work, basically, other than the Boolean one for this basic case. We also have a bunch of other SAS programs that we have written. We do not want to go through all of them in this particular setting. So all of them are free to be checked and thoroughly compiled and run or evaluated using our particular language. So that will be it from our end, and I hope this presentation was good enough. Thank you from each and every one of us.